So, Leonard Good. Another class with Leonard Good.
Yes. Well, this is going to be, somebody told me that you asked what an element was, and this is going to be about the elements. And this is a periodic table of the elements, and there's one on the wall there. It's not a wall really, it's a door. And you'll see them again. They are on the walls of drugstores and high schools and lecture halls and everything, and today we'll find out what it is. This is a table, and this is also a table. A table, in one sense, is a list of things in some kind of order. And it's often numbers, mathematical things, but in this case it's elements. So this is a list of the elements, not the elephants, and I have a little song to sing you, and if you want to memorize this, I'll give you a raisin. And the song goes like this. There's antimony, arsenic, aluminum, selenium, hydrogen and oxygen, nitrogen and rhenium, and nickel, neodymium, neptunium, germanium, iron, americium, ruthenium, uranium, europium, zirconium, luteum, vanadium, lanthanum and osmium and astatine and radium, gold and protactinium and indium and gallium, iodine, thorium and thulium and thallium. There's yttrium, ytterbium, actinium, rubidium, and boron, gadolinium, niobium, iridium, and strontium, and silicon, silver, and samarium, bismuth, chromium, lithium, beryllium, and barium, and holmium, and helium, and hafnium, and erbium, phosphorus, francium, fluorine, and ytterbium, manganese, and mercury, molybdenum, and magnesium, dysprosium, and scandium, and cerium, and cesium, and lead, praseodymium, platinum, plutonium, palladium, promethium, potassium, polonium, tantalum, technetium, titanium, tellurium, and cadmium, calcium, and chromium, and curium. There's sulfur, californium, and fermium, berkelium, and also mendelevium, einsteinium, nobelium, and argon, krypton, neon, radon, xenon, zinc, and rhodium, and chlorine, carbon, cobalt, copper, tungsten, tin, and sodium. These are the only ones of which the news has come to Harvard, and there may be many others, but they haven't been discovered. So some of those you may recognize. You know some of the elements already. This is made up of steel and plastic, but steel is not an element. Steel is made up of iron, which is an element, and carbon, which is another element. And you and I are made up of carbon and hydrogen and oxygen, and you can... Pardon?
Are we made of H2O?
Ah, what is H2O?
Water.
It's water. Now that's a formula. That means you could go next door with this as the recipe and borrow a cup of water. Of course, it'd be easier if you just turned on the tap, but nevertheless. And what this is a formula. It's like a little recipe. And it says water is made up of these things. Forget the two for a minute. What do you think H might be?
Hydrogen.
Very good. Hydrogen. Hydrogen's an element. It's up here by itself. And here's a cartoon of an atom of hydrogen. It has a thing in the middle that's called the nucleus, and a thing going around it that's called an electron. And that's all there is to it. Now I can't...
Oh, is oxygen?
And this is oxygen. Oxygen, remember when we had the candle underneath the little column, and we lit the candle and put the column over and it pulled the water up? Well, that's because it burned up the oxygen. And there's the air we breathe is mostly nitrogen, which is this one, the N. But oxygen is with it in the air. About, maybe a fifth of the air we breathe is oxygen. And here's a cartoon of oxygen. This is hydrogen. And oxygen is a little different. If you look, you can tell me what number... I better do this. And pardon my voice, I don't know what's wrong with me. This is O for oxygen. What's the number right up here? In this corner on your chart. Look for oxygen.
8.
8. Okay. Now how about in this column? What's the number at the very top in this column?
Dos. Dos.
Dos. Ay, muy bien. How about the next one?
The next 6.
6. Seis, if you will. Okay, now what that means is this. Here's oxygen. The center of it has 1, 2, 3, 4, 5, 6, 7, 8 things with a little plus charge, and 1, 2 electrons here, and 1, 2, 3, 4, 5, 6 electrons here. That's an atom. You probably have heard the term atom, and like the atom bomb and all of this. So I've got some elements to share with you and some things to do with them. Anyway, I would like to do one little thing. How about lead? Lead is Pb. It's way down at the bottom in the middle. And somebody tell me what number it is.
Wait, PB? Oh, yeah.
It's Pb. It's from...
It's 82.
Oh my gosh. Okay. Now that means that to make an atom of lead, a cartoon, I have to have 82 of these things in the middle. Forget it. And around the outside, I've got to have 2 electrons here. You can look and follow me. 8 electrons here. 18 electrons here. Oh no. 32 electrons here. 18 electrons. Oh, forget it. Now, I'm gonna get a piece of lead here to share with you.
On guard.
Now, for the moms and dads here, lead in its elemental form is not terribly dangerous. You don't want to eat it, but if you wash your hands before eating or smoking, you're okay. Anyway, you can pick it up. It's cold because it's been in the lab.
Oh.
But this is heavy as can be. And the reason it's heavy, if you look, is the atoms are heavy. It's made up of big fat atoms. And the things up near the top of the table tend to be light, and the things down near the bottom tend to be heavy. Look at this stairway. See this little heavier line? Can you see yours, Andrew?
Oh, yeah.
Okay, all the ones on this side are non-metals. All the ones on this side are metals. And the difference is non-metals don't carry an electric current very well, and they all have definite melting points. Now, that melting point is not a point like a sharp point, it's a temperature. So all these have a definite temperature at which they suddenly are liquid. And higher than that, they're a liquid, or maybe a gas, and lower than that, they're a solid. These don't. They just get mushy. Like silicon is Si, and it's the main ingredient in glass. And if you heat glass up, we'll do that. Not today, but we'll do that. It gets just sloppier and sloppier. Okay, I'm going to loan you an element here, and we're going to do some experiments with it. This is gold, and it's Au, and see if you can find it on the periodic table.
AU. 79.
Au, what number?
79.
Do you each have a piece of gold?
2 pieces.
Yeah, this is actually not the purest gold. This is eyeglass frames. But...
Hey, I don't have any. Ma'am, I don't have any.
Okay, now what we're going to do is take several metals, and you guys are going to be the chemists. But
wait,
I gotta
where's
have
AU?
your help here. I'm going to put some stuff in these test tubes. It's a liquid, and it's for the moms and dads here. It's soldering flux, and it's not terribly corrosive. But if you spill it, we'll have to stop doing what we're doing and deal with the spill. So try not to get it on your fingers, and please don't spill it. And it's hydrochloric acid, and it's the same acid that's in your tummy that helps you digest food. And I've got
But
this.
isn't ours a lot stronger in our tummies than that?
That's a good question. I think it's probably not quite as strong. So I'm going to put a little in each of these.
Won't it eat away at the glass?
No, it won't eat. It won't attack the glass. Oops, now I've got a spill to deal with. It won't attack the glass, or you said eat. The best word is react. And this is about chemical reactions. For example...
What can we put in there that... Will it eat this metal wire?
For example, if I take this lead and I put it on the table, that's the action. Well, there's no reaction. Some things, if you just put them together, something happens.
Oh, can we try putting this wire and dipping the wire in
Not
these?
yet. No, not that wire. We're going to put several metals. We know what they are.
Ooh, like
So
gold?
in the first one, on the left-hand side, let's be consistent here. You know your right from your left.
3.
On the left-hand side, put the gold. Just drop it in. You don't have yours yet, Andrew. I'll give you some.
No, I have a piece of gold.
Well, I mean, you don't have the acid.
So I should drop it in?
Yeah, just drop it in.
No.
Now, that's the action. There might be a reaction. There could be flames, could be a big explosion, could be smoke, could be a change in
happening.
temperature, all those things. Could be bubbles, all those things. And I wouldn't smell this one. Many times you can smell things to identify them, but this is kind of pungent and is irritating. But try not to get into this. So, is there any visible reaction with the gold?
No.
No. I'd like you to notice that the gold is down near the bottom of the table. And things down near the bottom are usually not very reactive. I'm going to pick it up. Let me pick them up, and then you can just leave them in the test tube. I don't see any reaction. I don't see any bubbles. I don't see any smoke. I don't feel any temperature change.
Yeah, it actually got almost even colder.
Can you feel the outside of it? I didn't spill any, so it's okay. Okay. It's gold. Gold is not very reactive. And you have heard the expression, acids eat things up. They don't have teeth. They don't have a stomach. They're just liquids. And they may or may not react with things. But the word is react, not eat up. Okay, the next metal I'm going to give you is
Ooh, goody. Nails.
Fe. See if you can tell what element is Fe.
Fe. Iron.
This is actually a steel nail, but it has enough iron in it to act like iron.
So should we put in our
Put it
second
in the
one?
second test tube, the one beside the gold.
Nothing. Nothing.
Well,
Nothing yet.
it's kind of cold out here, but you may see something.
Oh, it's turning yellow.
It may turn yellow.
Whoa.
Totally turning yellow.
What else?
There are bubbles.
Bubbles.
Nothing on mine.
Really?
Except for the yellow at the bottom. Now it's starting to bubble.
If you pick them up, Andrew, be really careful, please. I can see some bubbles. It looks like there's a little chemical reaction. And the longer it sits, the more bubbles you see.
And the more yellower.
Okay, which is more reactive, iron or gold?
Iron.
Indeed, it is. Very good.
Excuse me.
Which is higher up?
There's a line on this.
Which is higher up on the periodic table, iron or gold?
Iron.
It is, and that's not an accident. This is steel wool, but steel is mostly iron.
Ooh, I like steel wool.
And this, by the way, does not come from hydraulic rams. Now be real careful picking it up. But which is more reactive,
yellow.
the steel wool or the steel nail?
Well, what's happening to it? It's like growing.
Well, yeah, it's
The water's
reacting.
turning yellow.
It's reacting chemically with the acid. Okay, these are the same materials. Why do you think the steel wool reacts faster than the steel nail?
Because the steel wool's has more steel in it than the nail. I mean iron.
It's all just steel. What's the difference
Oh,
physically?
it has
Fuzzies.
Fuzzy. It's fuzzy. In other words, the acid can react with something when it touches it. And it can't touch the inside of the nail. It's got to react with the whole nail before it gets inside. But it's so spread out. It's got a lot of surface area, and so the acid can react with it all over. Okay, there's a third metal, and this is Al. What element do you think Al is?
Al.
Oh,
Aluminum.
yeah. Aluminum, great.
Oh, aluminum.
Let's put it in the third test tube, please.
Kayabunga!
Now, like many reactions, this is cold too. I should heat them all up and it'll work better. But like many reactions, they take a while. Some are instantaneous. We're
Well,
going to
mine
do
already
one that's...
started to bubble. like a lot.
Well, this will bubble so much, by the time we're done here, it'll disappear. And it bubbles faster and faster. And the bubbles, by the way, I would like you to notice, you can't tell any difference. They look just like air, but they're hydrogen. This is hydrogen gas.
Whoa, it's starting to disappear.
Well, it isn't starting. It's starting to react, but it isn't disappeared yet. This whole mess will turn kind of gray, and it will get warm too. We'll notice that.
Whoa!
Whoa, it's right. Look at the
many
steel
Whoa,
wool.
what the heck?
Steel wool.
Hey, there's something coming off of it, like smoke.
A fume.
Yeah.
If you hold it against a dark background, you can see this genie coming out. It stinks too. You don't want to smell that. It's pungent.
Well, Liam, look at that.
Pungent means it stings your nose a little bit.
I like it. Mine like when it's like this.
Okay, which is more reactive? Now think, use your wits. Which is more reactive, gold or aluminum?
Aluminum.
Well, yeah. Okay, the last one is another
This
metal,
one looks like it's almost getting warm.
and that is this. This is very reactive. We gotta be careful with this stuff.
Pokey, pokey.
This is little ribbons of what is called Mg. What element is Mg?
Liam.
Mg.
Yeah.
Oh, magnesium.
Okay, this is a little ribbon of magnesium, and I'd like you to drop it in the last test tube on the right. What happened to it?
It's gone.
It's gone.
Can we put another piece of...
If you can feel, you might feel a temperature change.
Yeah.
Yeah, if you put more, it gets really hot. Okay, which one is higher up on the periodic table? Now you need to think and look at your table. Which
Well,
is
this
higher
feel
up
mine.
on the
Start to get
periodic
warm.
table,
Feel it.
magnesium or aluminum?
They're both this.
Aha! They're both the same
Yeah.
as far as higher up goes. Which one is closer to the side of the periodic table, aluminum or magnesium?
Magnesium.
Things that are close to the side are very reactive. Things that are in the middle are not so reactive. Things that are high up are very reactive. Things that are lower down are not so reactive.
Oh, can we try helium?
Okay? Which is higher up? Andrew, think. Which is higher up on the table? Iron or magnesium?
Wait, where's iron again?
Here's iron, Fe.
Oh, yeah.
Which is higher on the table?
Iron or magnesium?
Yeah,
Magnesium.
it is. And also it's off to the left. Which is more reactive, iron or magnesium?
Magnesium.
It is. Very
Wait, which
good.
is magnesium?
Which is, okay, now I'm going to switch and see if I can trick you. Which is less reactive, gold or aluminum?
Gold.
Right, can't fool you guys. I would like you all to notice the relation. Things that are higher up tend to be reactive more than things low
Can we
down.
play with helium?
Pardon?
Can we try helium?
What is that?
Can we try helium?
Helium. I don't have any helium. Helium is in this column here. You'll see this one way off to the right, and it looks like it should be super reactive, except it's not. All of the ones in this column don't do anything.
What about this one?
Now this is sodium. This is elemental sodium, and you're not going to see it out in the real world because it doesn't exist for very long. It reacts violently with water, which is very strange. Now this is an element, not an elephant. And I got to get it out of here somehow. Watch this one. Salt is the formula. This is formula for water. This formula for salt is NaCl. One atom of sodium and one atom of chlorine. Okay, this is an explosive metal and this is a deadly war gas. And yet the two together make salt. And there's a lot of salt in your body. If you sweat, you taste your sweat, it tastes salty. If you cry, you taste your tears and they're salty. And the salt is very, very inert once it's reacted, but this is unreacted. This is sodium that's never been reacted with anything. It's very hard to find pure sodium. In fact, I had to buy this from a laboratory supply. And what it is a metal. I'll let you see in a minute. It's just so hard to get it out of here. And I want to put it on the plastic. And I want to get rid of this oily thing. It's kept in mineral oil so it won't react with the moisture in the air.
Can we touch it in the...
Don't touch it with your hands because you have moisture in your body. I'm going to give you each a little chunk of it. It cuts just like thick butter. And you can cut it. Don't knock it off the table or into your lap. And if you huff on it, you go... You notice it changes instantly. It looks like misty fuzz. It reacts with the water in your breath.
Will it react with double mint gum?
Well, if the gum has water in it, it would. But if you press on it, you can see you can cut it in half. And I wouldn't put the gum back in your mouth if you... You can see it makes an impression because it's soft. It's softer than lead, quite a bit. It's also very light. Doesn't weigh very much. It's pretty high up on the periodic table. Things that are high up are light. Things that are way down are heavy.
Would it react if we put it in that?
Don't do that. If you put that in there, it will react with almost explosive violence, and the whole column will come up on the ceiling and in your face. And
Awesome!
not to do that.
Now I know how to get back at my enemies. Fire!
Yeah,
Catch!
I was
What's
shooting
this?
rockets, and I told this boy, I says, you can take this rocket after it's gone off and put it in your dresser drawer, and all your clothes will smell like rotten eggs. And he says, I'm going to put it in my sister's drawer. Anyway, what we're going to do is, even though it's raining a little bit, I'd like to go out and put some of this in the water just because you'll never see it again. Be careful where you hold it so you don't want it to fall off in your lap. So let's put them together. Let's see, let's cut that one in half so it'll react faster. You've got yours in tiny pieces, that's great. Oh, I missed the sun.
Oh! Fireworks!
Yeah, fireworks. Now, you wouldn't want to eat that, right?
Definitely not. I'll do it.
Yeah, you don't know behind.
Hurry up! Whoa!
Now, you wouldn't want to put that stuff in your pocket. And you certainly wouldn't want to eat it.
Because you have water inside.
That is half of sodium chloride, which is table salt. I'm going to dip this in. Whoa!
That's brown.
Yeah. That is brown. And if you look on the chart,
That's a 14.
14. This is very basic. This is, it reacted, the sodium reacted with the water, and it made what is called sodium hydroxide, which is lye. That's caustic lye. Nasty stuff. Sodium by itself is an explosive metal, and if you put it in water, it makes a corrosive
Do they use that stuff in
substance.
fireworks?
No, it's too dangerous. They use magnesium in fireworks. In fact, I just was cleaning my desk, and I found a firecracker. Often, when I was a kid, you'd do this and open it up, and it was a Chinese newspaper, because most of the firecrackers are made in China, and you could see all the Chinese characters in the paper in the firecracker.
I know.
Now, this is a mixture of gunpowder and magnesium, and they do that on purpose so it will be bright. They're called on the package flashlight crackers because they flash. And I'm going to see if we can set it off.
It's fire and it cracks. Literally.
This is about the last thing we'll do. We'll want to get out of here right after.
Why?
It'll stink. Whoa! Another
Too bright.
mushroom cloud.
You can light it some more.
There's nothing to burn.
Can I
You can't burn a match twice. Once it's burned, it's burned. There might be a little shred of it around the edges, but I don't think so. That's all I have to share with you, and we'll do more next time with chemistry and science stuff.
Liam, look. You can make this one light yourself.
There's antimony, arsenic, aluminum, selenium, hydrogen, oxygen, nitrogen, and rhenium, and nickel, neodymium, neptunium, germanium, iron, americium, ruthenium, uranium.
These are the only ones of which the news has come to Harvard, and there may be many others, but they haven't been discovered.